Hi, I'm Hassan, the lecturer here at the Institute of Medical Education, and today we're going to take a look at solutions to Section 3 of ACER's GAMSAT Pink Booklet, Practice Test 3, specifically Unit 2, questions 5 to 7. And in this unit, we've been given four graphs that show the same vowel sound when produced through the vocal tract under different conditions. The important thing about this unit is that you actually don't require any prior knowledge in physics nor knowledge and analysis of sound waves. So it just requires a very keen eye. So take note of the distances in periods. So remember, a period is the distance between the two amplitudes or the two peaks. And take note in the actual fundamental and resulting resonances. So you've got here your fundamental resonance. So let's say you clap your hands. That's the initial sound. But then you've got these residual sound waves after, and they kind of dissipate or they disappear. So take note of also the residual, or what they call the resulting resonance. So take note of those, take note of the periods, and take note that obviously they're showing you there's two halves to this figure. So, or to the four graphs, you've got on the left-hand side, you've got the glottal pulse rate, and on the right-hand side, you've got the vocal tract length. So take note of that. So before we dive in, yes, you don't need to have any background in physics. It's imperative that please, I tell this to students all the time, arithmetic is important. So knowing how to do simple addition, subtraction, multiplication, manipulating these sorts of formulae. So it's telling you frequency equals 1 over period. You have to know how to use, say, scientific notation and how to derive answers using fractions. So when we look at question, we'll jump the gun here. If we take a look at question 5, it says, what is the frequency of the sound produced through the short vocal tract length? If you take a look at the figure on the right-hand side, the vocal tract length for short has the same period, so the same t value as the long vocal tract length, and it tells us that it's 8 milliseconds. So note it's 8 milliseconds, which is the same as 8 by 10 to the minus 3. So we've got here millisecond. So it's important to note, if we want to find what the frequency is, we're told that frequency equals 1 over our period. So it's going to be, well, 1 over 8 by 10 to the minus 3, and that's our answer. So, but how do we answer this without a calculator? So there are a couple of ways you can attack this. You find what works for you, but I'll give you a couple of options. So the first option is you can just say, well, 1 over 8 is equal to 0.125. You should know this off by heart. So it's important that you memorize from, say, fractions 1 over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You memorize all of them because it saves you time in the GAMSAT to answer questions like this. So you can say it's 0.125, and we know that it's a millisecond, so times 1,000. So therefore, it's going to equal, that times 1,000 is 125 hertz. That's one way of answering it. Another way of answering it is saying, well, 1 over 8 by 10 to the minus 3, so 1 over 0.008 is the same as saying, well, how many times does 0.008 go into 1? Well, you can say if you times this by 100, we get 0.8. And then we know that a quarter of 100 is 25. So a quarter of 8 is going to be 2. So if we times that by 125, we're going to get 1. So therefore, the answer is 125 hertz. You can find a method for yourself, but the key is don't try to figure out the method during the exam. Figure out your method before the exam. So the answer for 5, therefore, has to be D. So if we move on now to question 6, it asks, compared with a long vocal tract length for a short vocal tract length, what do we have? So let's have a look at the long and the short. So for the long and short vocal tract lengths, we see that the periods, so the t values, are the same. So if the period is the same, the frequency is going to be the same. So therefore, we know for question 6, the answer can't be A or D. It has to be between B and C. So it's the resonance. So the only difference is if you take a look at the decay of the resonance for the resulting resonance. You can look at the fundamental, but have a look and see how the long vocal tract, the resonance, the amplitudes of the peak for the long vocal tract of the resulting resonance, so these amplitudes, they're a lot larger than the short vocal tract length. And they look like they're definitely bigger and they have more volume in the sound. So therefore, just by that principle alone, if we're looking for a short vocal tract length, the sound is going to decay much more quickly because you can see the sound's almost non-existent. So therefore, the answer for 6 has to be C. So C, the resonance decays much more quickly. And it's obvious, again, you don't need to have a background in physics or physics of sound waves. You can just eyeball and see if there's no wave there, then obviously the sound wave is decayed. So that's a way to look at it using your eye. So question 7, the last question here, it kind of goes on from question 6. He asks, a longer vocal cord tract length and a faster glottal pulse rate results in a period. So let's just take a look. Remember, we split the graphs into 2 halves. Let's take a look at the left-hand side with the glottal pulse rate. So we see that the fast, so we can say this is fast and this is the slow glottal pulse rate. We see that the T, the period, is much smaller here or shorter than the period here. So this is half and this is, let's say, 1. So you can see that a fast glottal pulse rate is going to have a shorter or a decreased period. So we know that. So we know it's going to have, the period is going to be decreased, so we know the answer can't be B or D. So it's going to be between A or C, A or C. Does the resonance last longer or does the resonance reduce more quickly? So let's take a look on the right-hand side of our graph, of our figures, the short vocal tract length and the long vocal tract length. And remember, it's asking us for a longer vocal tract length. We see that the long vocal tract length, if I just draw it crudely here, so can you see how the sound is big, whereas the short vocal tract length, the sound kind of disappears? So you can see here that the sound is obviously decaying much slower. So the sound is lasting longer. So the sound here lasts longer because you can see there's still a sound wave. So therefore, the answer for 7 has to be, well, it can't be C because it says it reduces more quickly. No, it doesn't. It's got a bigger oomph. Think about the sound when you listen to music. It's got a bigger punch than it does here. So the answer can't be C, so the answer has to be A. So these, look, you didn't have to have a background knowledge in physics. You kind of did have to know what a period is. it would have helped if you knew what frequency, period, amplitude was. But this question, kind of like a lot of the questions in this practice test 3, the pink booklet, a lot of them you don't actually have to have a background knowledge in the physics or the chemistry or the biology. You just have to have a very keen eye. And I think it's important in the GAMSAT to know that a lot of the times you can just use the stimulus to answer the question. It's like an aptitude test. So you might not know the background completely, but if you just use some deductive reasoning and use a keen eye and just read properly, you'll be fine. If you're still having problems with this question, you can post them in the comment section below, or you can contact us directly. We'd love to help. Thanks for your time. Bye now.